Hello everyone, in this video I'm going to explain the concepts of prompt engineering. In this video I will explain zero-shot learning, one-shot learning, few-shot learning, and some similar concepts are zero-shot prompting, one-shot prompting, and few-shot prompting. Prompt engineering. So this engineering is performed to improve the accuracy of machine learning models by improving the prompts that are given as inputs to these models. For example, when you give inputs to the models like ChatGPT, it will process the prompts and generate the answers. So it will generate the answers based on the prompts, but its accuracy depend on the quality of the prompts. Prompt engineering is a crucial concept in working with AI language models, especially when using them for tasks like text generation, question answering, summarization, or any other specific applications. It involves crafting and refining prompts to elicit the desired responses from the model. So the definition of prompt engineering and some examples some examples can be like when we give inputs to the machine learning model, or when we give examples to the machine model, it will make predictions based on the examples. So in zero-shot learning, we give zero examples to the machine learning model, and in few-shot learning we provide few examples to the model, and in one-shot learning we give only one example to the machine learning model. So this enables machine learning model to make predictions for new classes with limited labeled data or examples. In this case, some examples are provided to the machine learning model, and the model makes predictions based on the examples, and or we can give new input to the model. In one-shot learning, so each new class has one labeled example. So in this case, the goal is to make predictions for the new classes based on the single example. One-shot learning refers to a machine learning paradigm where a model is trained to recognize or classify an object or perform a task using only one example or a very limited number of examples. So in this context, the model is expected to generalize from this single instance to make prediction decisions about new unseen data. So in this learning, we provide only one example to the machine learning model, and the machine learning model will make predictions based on these examples for new input or unseen data. For example, if I provide, for example, in this case, if I provide one example to the machine learning model, then it should be one-shot learning, one example. And after that, if I provide, it will be, and after that, I will provide the unseen data like for new input. So then it will classify this input based on this example. Classification will be based on these examples. So some key features of, there are some certain advantages of one-shot learning. It requires minimal data, and it improves the generalization and applications of machine model for new and unseen data. Zero-shot learning. So in zero-shot learning, we provide no examples or examples to the no examples to the machine model. We provide zero examples. So in this case, the model will generalize to unseen data based on its previous knowledge. So in zero-shot learning, we ask the model to perform a task or answer a question without having been explicitly trained on that specific task or given any examples to guide it. So zero-shot is useful when the model is required to generalize to new tasks or domains it has not encountered before. Zero-shot is useful when the model is required to generalize to new tasks or domains it has not encountered before. Few-shot learning involves providing a model with some limited examples or a small number of shots of how to solve a task before asking it to perform the task itself. So in this case, we provide some examples to the machine learning model, some examples to the machine learning model. Say for example 3 examples or n examples. And then if we ask the model, for example for new data, we'll give it new data point, and then it will make predictions based on that data. Predictions based on that data. Examples based on these examples. Output will be based on these examples. Context of the problem. Based on the context of the examples. So the strength of few-shot learning is allows the model to adapt to a specific task or improve accuracy and relevance when examples are given. Few-shot learning or chain of thought. Few-shot chain of thought is an extension of few-shot learning, where the examples not only demonstrate how to solve the task but also explicitly show the reasoning process. So in this case, the examples will also show the sequential steps that will define how to solve the problem appropriately. So the model then learns to break down the problem step by step in its responses. The strength. This helps improve the model's reasoning capabilities, particularly in multi-step or complex tasks that require logical progression to reach an answer. So in this case, this type of learning will improve the model's logical reasoning capabilities. So the model will perform the complex tasks in a more accurate way or in a better way. So a few-shot chain of thought learning is very significant for improving the accuracy of the machine learning model. For example, if I give the sequential steps of solving a problem in prompt to ChatGPT, it will provide the answers in more generalized and more better way based on the provided examples. And then zero-shot some examples of zero-shot learning are, for example, if I ask the ChatGPT what is the capital of France, so even though I have not been given any prior examples of answering this specific question in the current conversation, I know from my training that the answer is Paris. For example, for the ChatGPT knows from that the answer is Paris, and then so if I ask what is the capital of France, then the ChatGPT says the capital is Paris. Some examples of one-shot learning are classifying a new image based on one example. So if I provide an image of a dog, and I give this image as an example in a prompt, and then I say that this is a specific type of dog, let's say golden retriever, and I label that it is golden retriever. Then I will ask in the prompt that classify the following image as either golden retriever or not golden retriever based on the example provided. And then I will give a new image of another golden retriever. And the ChatGPT will give the answers based on an example. For example, if I give another picture of golden retriever, then ChatGPT generates the image is classified as golden retriever because it matches the example provided. Explanation. In this one-shot scenario, the model should recognize the breed based on only a single image or the example of the golden retriever, and is then asked to classify another instance of that breed. So the goal is for the model to generalize from that one example to correctly identify similar images. Few-shot example. Some examples of few-shot learning are, for example, if I want to perform the task of translation from English to French, then I'll give some examples in prompt. Some examples could be like translating some sentences into French, and then I'll ask and then I'll give a question to ChatGPT for translation. For example, I can give the sentence, where is the library? So that ChatGPT responds in French, and then and it will follow the examples that I have provided. Few-shot chain of thought examples. So in few-shot chain of thought, I'll give the steps. I will show how to solve the problems in a step-by-step manner. For example, if I give the problem, if Alice has 3 apples and buys 2 more, how many does she have now? then I will provide the steps as well. For example, in step 1, and starts with 3 apples. In step 2, she buys 2 more. So we add 3 plus 2. Step 3, the answer is 5. Example 2. If a train travels 60 miles in 2 hours, how fast it is going? We know the distance is 60 miles and time is 2 hours. Speed, and the formula of the speed is also given. And in the last step, I will give the answer by showing how to calculate the speed from the given formula. So in this case, if I ask ChatGPT a similar problem, then ChatGPT follow the same reasoning process to reach the answer. Conclusion: prompt engineering. So we have learned that prompt engineering is a very powerful tool that can significantly influence the effectiveness of AI language models. So if I carefully design the prompts, so I can improve the accuracy, relevance, and utility of the response generated. So in this way, the technology will be more accessible and effective for various tasks. Thanks for watching this video. Please subscribe to my channel and share these videos to your friends and family.